Here we are asked to find the limit of each function as x approaches positive infinity. We notice that in these four functions, the numerators are constants and the denominators are powers of x. So f of x, we have 2 divided by x to the first power. In g of x, we have 5 divided by x to the first power. H of x is equal to 3 divided by x to the second power, and m of x is equal to negative 5 divided by x to the third power. So if we want to find the limit of these functions as x approaches infinity, we are going to make the x values become very, very large. And so what happens when we divide a constant by a very, very large number? We know that the answer will be very, very close to 0. And so we say that the limit of f of x as x approaches infinity is equal to 0. It doesn't mean that f of x is equal to 0 at infinity. It just means that the number or the value of f of x gets closer and closer to 0. So if the same thing will happen to g of x. If x is very, very large, then when we divide 5 by that very, very large number, the answer is very, very close to 0. So again, we will say that the limit of g of x as x approaches infinity is equal to 0. Now, for h of x, we are going to make x very, very large and then square that very, very large number and then divide 3 by that very, very large number. And so the answer must be very, very close to 0. So we'll say here that the limit of h of x as x approaches infinity is equal to 0. And for m of x, when we cube that very, very large number, then we get a very, very large number. And when we divide negative 5 by that very large number, the answer will be very, very close to 0. So we'll say that the limit of m of x as x approaches infinity is equal to 0. Now, let us look at the graphs to see if our answers are agreeing with the graphs. So let's see, what's a graph of f of x? Okay, here's the graph of f of x, and we notice that as we go farther and farther to the right, meaning we are making x larger and larger, the value of x is getting, rather the value of y is getting closer and closer to 0. So there it is. Okay, so that means our answer here makes sense. Now, how about for g of x? Same thing. For h of x, it's the same thing. The function gets closer and closer to 0. It's like flat, and it's just get very close to the x-axis. That means it's very close. The y value is very close to 0. And for m of x, it's the same thing.